Hi, I'm Freddie Zhang. I live in Vancouver, British Columbia, Canada, and my CS50x final project is titled HonOR, Classifying Machine-Generated Text at Scale. While artificial intelligence has the potential to revolutionize industries and bring benefits to greater society, its risks cannot be understated. AI and ML technologies are biased, discriminatory, easily exploitable, and have limited robustness and real-world grounding. I propose that a generalized detector for machine-generated content would help alleviate some of this risk. By identifying artificial text, one may evaluate such text with appropriate reservations. For my project, I created an AI model to detect computer-generated text. For human-written text, my dataset was derived from the Pile, a diverse dataset from the Luther AI, made up of 22 smaller datasets, including a modified version of Common Crawl, PubMed Central, ArcSiv, Wikipedia, and Bibliothèque. In terms of computer-generated text, I relied on a 2008 GPT-3 output samples that OpenAI provided upon release of the model. In this sense, my model is most optimized for GPT-3, which I believe is suitable for the current usage landscape, as GPT-3 is a dominant model. For model implementation, I relied on PyTorch and transformers. I trained 10 models in total. The best performing was a BERT for sequence classification 1. Ultimately, I created a Gradio interface hosted on Hugging Face that allows users to input text and receive a classification along with the certainty of it as a percentage. My site is optimized for all devices, both desktop and mobile. This is an example of where the model correctly classified ChatGPT output as machine-generated, and this is an example where it identified Wikipedia text as human-written. During testing, my project showed 98.9% accuracy. It also has a minimal carbon emission per run of roughly 14.46 grams. This also alludes to the software's performance and ability to run on limited infrastructure. Under the hood, as artificial intelligence models do operate, the model may have learned to calculate the probability that a word may appear after another and use that to gauge whether a text is automatically generated, similar to how GLTR by Strobelt et al. Works. In conclusion, I hope that my model will be another tool available to aid in the detection of generated text and in turn awareness of the limitations of large language models. I believe that the current state of AI and ML suggests that they should be utilized as an assistant with a human in the loop, not in the driver's seat, considering their limitations. Thank you so much for watching. This was HonOR and CS50.